Okay, let's take a look at an example of optimizing with linear programming. So we're going to graph the system of inequalities, we're going to name the coordinates of the vertices of the feasible region, and we're going to find the minimum and the maximum. So since we're finding the minimum and the maximum, that means they've given us an optimizing equation, which is this one right here. So we're going to focus on graphing our system of inequalities, which are these three right here. So I'm just going to go ahead and start, and I'm going to graph the first one here. I'm going to call this one A. So when we're graphing this inequality, what ends up happening is we're going to graph two lines. We're going to graph the line y equals -2, and we're going to graph the line y equals 6. Now, I changed these to equal signs because the inequalities here will tell us which regions to shade, and it will tell us if it's a dotted line or a solid line. But in the end, we're just graphing y equals -2. So I'm going to go to where y equals -2. Boom. And I'm gonna count by twos here, my scale. So this is -2 right here. And I'm gonna draw my vertical line, which is a solid line at -2. There's my first region. Okay, next graph. I'm going to graph y equals 6. So when y is 6, 2, 4, 6, I have another vertical line. Okay, easy enough. Now I need to shade my region. So y is greater than -2, greater than or equal to -2, but it's less than or equal to +6. So I'm going to shade where it's greater than -2, so this area here, but it's less than 6, so this area down here. So I'm going to shade this. Let's just shade this one in yellow. Okay. Now we're just going to move on to our next graph. And we can do this one in green. And that is not C, it's B. Okay, first thing I need to do, put it in slope-intercept form. So putting this in slope-intercept form, I'm just going to divide each side by 3, and then we'll have y equals mx plus b. So y is less than or equal to 4/3 x plus 26 divided by 3, which ends up being about 8.7. All right, now again, all I'm going to do is graph this line, and the inequality sign is going to show me which region do I need to shade, and is it a dotted or solid line. So I can rewrite this equation because I'm just going to graph the line y equals 4/3 x plus 8.7. Same exact thing. So y-intercept is 8.7. So going up to 2, 4, 6, 8, and then about one more. My y-intercept is right there, and my slope is 4/3. So I can go up 4/3, or I can go down 4 to 4/3, which would be about right here. Down 4 to 4/3, about here. So my line, again, is solid because it's equal to. Should look something like so. Okay, and now I'm going to shade. So y is less than, there's two ways I can do it. The way that I like to is I look here and I say y is less than. So wherever the y values are less than of the equation is where I'm going to shade. So I know it's going to be below the line here. Okay, so our green area is our overlapping region for now. Now the other way you can solve to see which region you need to shade is you can plug in a point. So 0, 0 is definitely to the right here. If I plug in a 0, 0 to this equation, it's going to be 3 times 0 is less than 4 times 0 plus 26. So 0 is less than or equal to 26. And that is correct. So I shade the region where 0, 0 is the solution. So either way you want to do it is fine. Now let's graph the last one. Graph this one in blue. Okay, so equation C is already in slope-intercept form for us. So all I need to do is graph the line. The y-intercept is 2. So I'm starting at 2, which is right here. And the slope is -2. So I'm going to go up 2 and left 1, up 2 and left 1, up 2, left 1. So my line looks like this. And again, it's a solid line because the inequality is equal to. All right, now to figure out the area which to shade. Let's shade this one in purple. All right, so y is less than the equation. So I'm going to shade where all the y values are less than, which is underneath the line. So I'm going to shade here, everywhere underneath. And if you want to, like last time, you can plug in the point 0, 0 again, and you can figure out that 0 is less than or equal to negative 2 times 0 plus 2. So 0 is less than or equal to 2. That is correct. So we shade the area where 0, 0 is the solution. And now, in the end, we have our shaded triangle right here. This is our bounded region. So since it's bounded, we will have a minimum and a maximum. And we're going to first find the vertices so we can figure out what the minimum and the maximum are. So let's figure out this first vertice right here. So in order to find this vertice, I'm going to figure out which two lines are intersecting. And I'm going to solve for where they intersect. So it's intersecting with this line right here, and this is the line y equals 6. It's also intersecting with this line right here, which is our green one, which is, well, I want to intersect it with C. I'm going to use this line here because they're all intersecting at the same point here. So this line is y equals negative 2x plus 2. So I'm going to pick a different color too so we can see this. So our first vertice, we know y is 6, and the next equation is y equals negative 2x plus 2. So the best way to solve this system of equations is with substitution. So I'm going to plug 6 in for y. 6 equals negative 2x plus 2. Simplify this. We'll subtract 2 from each side, and we'll get 4 equals negative 2x. So x is negative 2. So our x value is negative 2, and our y value we already said was 6. So the first point for our vertex, for our first vertex, is negative 2, 6. Okay, on to the next one. Let's figure out the vertex for this point right here. So this point crosses through, or is the intersection of this line, which is y equals negative 2, and this line right here, which is this line right here. So it is, well, we can just say it's the original equation, which is 3y less than or equal to 4x plus 26. So if we figure out where these two lines intersect, we will find the vertex. And we know y is negative 2, so we're just going to substitute negative 2 in for y and figure out our x and y values. So 3 times negative 2 is equal to 4x plus 26. And don't be confused because I changed this to equals to, because remember our inequality tells us which area to shade. This is still the same line. So I have negative 6 equals 4x plus 28. Oh, not 28, 26. So now I'm going to subtract 26 from both sides, and I should get negative 32 equals 4x, and x equals negative 8. So our second vertex is negative 8, and y, like we said, is negative 2, so negative 8, negative 2. And our last vertex, we're going to find this one right here. So again, we're using the line y equals negative 2, and this time we're using the next line, which is this one here, y equals negative 2x plus 2. So I'm going to solve this system of inequalities, and I'm going to use substitution again. So y, which is negative 2, we said, equals negative 2x plus 2. Subtract 2 from both sides, and we get negative 4 equals negative 2x, and x equals 2. So our last vertex, x is 2, and y is negative 2. Okay, there we go. Next thing we need to do is find the minimum and the maximum, and we're through. All right, so we've got our vertex, or our vertice. Now we need to set up our table so we can solve for the minimum and the maximum. So we're going to plug in our x and our y value. We're going to plug it into our optimizing equation, which is negative 3x minus 6y. So we have negative 3x minus 6y, and then our ending result is going to be f of whatever we get when we plug in x and y. So our first vertex, negative 8, negative 2. Well, this was our second, but it's one of our vertices, our vertices. We have negative 3 times negative 8 minus 6, and y is negative 2. Multiply that out, and we will get 36. Next vertex, 2, negative 2. Plug that in, and we get negative 3 times 2 minus 6 times y, which is negative 2. Multiply all of that out, and we will get 6. Last vertex, negative 2, 6. Plug that in for our optimizing equation, and we get negative 3 times negative 2 minus 6 times positive 6, and we multiply that one out, and we get a whopping negative 30. Okay, so looking at our graph, we know that the minimum has to be one of our vertex, and our maximum has to be another one of our vertex. So looking at our final values, we have discovered this is our max because it is the biggest one, and our minimum is this one right here. Okay, hope this video helped, and I'll see you later.